500,000 miles, 0 engine rebuilds, still getting 50 miles per gallon. This isn't a unicorn. This is a Tuesday for Toyota hybrid owners. And today, I'm breaking down the 8 engineering choices that make it happen and why some other automakers took a different path. Before we start, one click on subscribe helps us create more videos like this. Let's get started. Reason 1. The Atkinson cycle advantage. First up, Toyota doesn't use a conventional engine cycle. They use the Atkinson cycle. Here's what that means in plain English. The engine trades a little peak power for massive thermal efficiency, less wasted heat, less mechanical stress, less wear. A conventional Otto cycle engine converts more energy into heat rather than motion. Toyota's design captures more of that energy as usable power. That's why a Prius engine at 300,000 miles often shows less cylinder wear than many conventional engines at 80,000. Reason 2. The electric motor isn't just for saving gas. It acts as a mechanical bodyguard for the engine. Every cold start, every hard acceleration, every low-speed crawl, the electric motor handles it. The gas engine? It mostly cruises at its optimal RPM, like a jogger who never sprints. No cold start wear, no lugging, no abuse. By the time a Toyota hybrid engine hits 400,000 miles, it's lived a softer life than many conventional engines at 100,000. Reason 3. The eCVT has no belts to wear. Okay, this one is genuinely fascinating. Most CVTs on the market, regardless of brand, use a metal belt and pulley system. It's a design that creates inherent friction and wear over time. Toyota's eCVT, no belts, no pulleys, no friction-based power transfer, just planetary gears and electric motors splitting power through a fixed mechanical path. It's a transmission design that mathematically cannot slip in the way a belt-driven CVT can. Reason 4. The battery stays in its happy zone. Toyota programs the battery to stay between roughly 40% and 80% charge, always, never full, never empty. This is the same principle used to protect high-end battery packs. Keeping lithium-ion in the middle of its charge window minimizes dendrite formation and thermal stress. The battery essentially operates in a reduced stress zone for its entire life. Reason 5. Regenerative braking saves the brakes. Brake jobs every 20,000 miles. Not on a hybrid. Regenerative braking converts your momentum back into electricity before the physical brakes even engage. Most Prius owners replace brake pads well past 100,000 miles. Some go much longer. The engine doesn't just last. The whole car experiences less mechanical stress. Reason 6. Toyota uses triple redundant cooling. Heat kills engines. Toyota engineered 3 independent cooling loops. Engine coolant, inverter coolant, battery coolant, each with its own radiator, pump, and thermostat. While some competitors use shared or simplified cooling systems, Toyota runs triple redundancy. It's conservative engineering, and that conservatism pays off over 500,000 miles. Reason 7. The software prioritizes longevity over excitement. Toyota's engine management software isn't tuned for drama. It doesn't overboost. It doesn't let you redline on a cold morning. It just protects things. Conservative timing. Protective mixtures when needed. Aggressive knock detection. It's like having a cautious engineer running your engine. Not exciting if you want raw power, but unbeatable if you want 500,000 miles. Reason 8. They tested this to destruction before selling it. Before the first Prius reached American dealerships, Toyota ran prototype engines for the equivalent of hundreds of thousands of miles in climate chambers. Desert heat, sub-zero cold, salt spray. They found failure points and engineered them out. Some competitors rushed hybrids to market to meet emissions deadlines. Toyota spent years in validation. There's a reason you still see early Prius models running daily Uber shifts in 2026. So here's the reality. Toyota hybrids don't last because of one magic bullet. They last because of 8 layers of conservative engineering, each one backing up the others. Atkinson cycle, electric motor protection, gear-based transmission, battery charge limits, regenerative braking, triple cooling, protective software, brutal testing. 500,000 miles isn't luck. It's intentional engineering. Drop a comment. What's the highest mileage you've seen on a Toyota hybrid? And if this made you rethink your next car purchase, hit subscribe. I break down the engineering that actually matters.